In this tutorial, we are going to build a simple calculator in Python. Our calculator will support addition, subtraction, multiplication, and division. The user will choose an operation, enter two numbers, and the calculator will display the result. And instead of stopping after one calculation, we'll keep the calculator running until the user chooses to exit. We'll also organize the program using functions so that each part of the calculator has a clear purpose. Let's start by creating a new Python file. We'll call it calculator.py. Let's create the part of the program that actually performs the calculation. For that, we create a function called calculate. The function will receive three values: the first number, the second number, and the operator selected by the user. So we'll use number 1, number 2, and operator as the parameters. Now, based on the operator, we need to decide which calculation to perform. Let's start with addition. If the operator is equal to the plus symbol, we'll return number 1 plus number 2. Here we use two equal signs because we are comparing the operator with the plus symbol. Next, we'll use elif and check for the minus symbol. If that condition is true, we'll return number 1 minus number 2. Then we'll check for the multiplication symbol, asterisk. If the user selects it, we'll return number 1 multiplied by number 2. And finally, we'll check for the forward slash. If the operator is a forward slash, we'll return number 1 divided by number 2. So our calculate function now has one job. It receives two numbers and an operator, performs the required calculation, and returns the result. We'll define a function called main. This part will handle the interaction with the user. It will ask for the operator and numbers, call the calculate function, display the result, and keep the calculator running. We don't need to pass any parameters to this function. This function will control the overall flow of our calculator. Inside the main function, we'll use a while loop. We'll write while true. This keeps the loop running until we explicitly stop it using a break statement. Inside the loop, we'll first ask the user which operation they want to perform. We'll display the available operators: plus for addition, minus for subtraction, asterisk for multiplication, and forward slash for division. We'll also allow the user to enter Q when they want to quit. The value entered by the user will be stored in a variable called operator. Before asking for any numbers, let's check whether the user wants to exit. If operator is equal to Q, we'll display calculator closed. Then we'll use break. Break immediately stops the while loop. To make the comparison case insensitive, we can convert the operator to lowercase. This way, whether user enters lowercase or uppercase Q, the calculator closes. Since this loop is inside our main function, once the loop stops, the main function also reaches its end. Let's test this. At the bottom of our file, we'll call the main function. Now run the program. Enter Q. As you can see, the program displays calculator closed and exits. Now we have to handle the case where user enters an operator that our calculator does not support. There is no reason to ask for two numbers if the operation itself is invalid. So let's check the operator before continuing. We'll check whether the operator is not one of plus, minus, asterisk, or forward slash. If it is invalid, we'll display invalid operator. Then we'll use continue. Continue skips the remaining statements in the current loop iteration and starts the next iteration. So instead of closing the calculator, Python goes back to the beginning of the while loop and asks for another operator. Let's test it. Run the program. Enter the percentage symbol. Python displays invalid operator. And then the calculator immediately asks for an operator again. Once we know that the operator is valid, we can ask for the two numbers. We create a variable called number1. Then we'll use the input function and ask the user to enter the first number. We'll do the same for number 2. But remember, input gives us text. We want to perform calculations with these values. So we'll convert each input using float. Using float allows our calculator to work with whole numbers as well as decimal numbers. Now there is a small problem we need to handle. What happens if the user enters something like hello instead of a number? The float conversion will fail and Python will raise a value error. Since this is an interactive calculator, we don't want the entire program to stop because of one invalid input. So we'll place the number input and calculation inside a try block. Then we'll add an except block for value error. If the user enters something that cannot be converted into a number, we'll display please enter valid numbers. Once the except block finishes, the while loop starts its next iteration. So the user can try again without restarting the program. Let's test it. Select addition. For the first number, enter hello. As you can see, the program does not stop. Once we have the numbers, we'll call our calculate function. We'll pass number 1, number 2, an operator to it. The calculate function checks the operator, performs the correct calculation, and returns the result. We'll store that return value in a variable called result. Then we'll print the result. Let's run it. Now let's enter valid values. Choose the plus operator. Enter 10 for the first number and 5 for the second number. We get 15. And notice what happens next. The program does not stop. Because all of this is inside our while loop, the calculator immediately asks us to choose another operation. Let's test addition once more. Choose plus. Enter 12. Then enter 8. So the result is 20. Now choose the minus operator. Enter 12. Then enter 8. This time, the subtraction condition inside the calculate function is used. The result is 4. Now let's select the asterisk. Enter 12 and 8. The calculate function multiplies the two numbers. The result is 96. Now let's try division. Choose the forward slash. Enter 12 and enter 8. The result is 1.5. There is one more error we should handle. Let's choose division again. Enter 10 as the first number and 0 as the second number. When the calculate function tries to divide 10 by 0, Python raises a 0 division error. We don't want that error to stop the calculator. So we'll add another except block. This time, we'll handle 0 division error. Inside it, we'll display cannot divide by 0. Let's run the same calculation again. Enter 10. Enter 0. This time, instead of the program stopping with an error, it displays cannot divide by 0. Then the while loop continues and the calculator is ready for another calculation. At this point, our main function contains the complete application flow. But at the bottom of the file, instead of calling main directly, let's use the standard Python main check. You will commonly see this pattern in Python programs. When we run this file directly, Python sets the special name variable to main. So this condition becomes true and the main function is called. For this project, the important thing to understand is that this gives our program a clear starting point. The calculate function handles the calculations. The main function controls the application. And this final condition starts the application when we run calculator.py. Now let's look at the complete flow. When we run the file, Python reaches the main check at the bottom. Since we are running the file directly, the main function is called. Inside main, the while loop starts. The calculator asks the user to choose an operator. If the user enters Q, break stops the loop and the calculator closes. If the user enters an invalid operator, continue takes us back to the beginning of the loop. If the operator is valid, we ask for two numbers. The try block allows us to process those values safely. Then we call the calculate function. The calculate function performs the selected operation and returns the result. Then we display that result. If the user enters something that cannot be converted into a number, value error is handled. If the calculation tries to divide by 0, 0 division error is handled. After the calculation or after handling an error, the loop starts again. So the calculator keeps running until the user chooses to quit. Now let's test the complete calculator from beginning to end. First, choose addition. Enter 25 and 10. The result is 35. The calculator stays open. Now choose subtraction. Enter 25 and 10. The result is 15. Next, choose multiplication. Enter 5 and 6. The result is 30. Now choose division. Enter 10 and 4. The result is 2.5. Let's also test an invalid operator. Enter a percentage symbol. We get invalid operator. And the calculator asks for another operator. Now select addition and enter an invalid value instead of a number. We get please enter valid numbers. The calculator still continues running. Now let's test division by 0. Choose division. Enter 10 and 0. We get cannot divide by 0. And again the program continues. Finally let's enter Q. The program displays calculator closed. Break stops the while loop. The main function finishes. And our program ends. So our calculator now behaves like a small interactive application instead of running only once. We use the calculate function to keep the calculation logic separate. We use the main function to control the overall application flow. We used if and elif conditions to decide which operation should be performed. We used a while loop to keep the calculator running. We use break to exit the calculator. We use continue to start the next loop iteration when the operator is invalid. We use try and except to handle invalid numbers and division by 0 without stopping the application. And finally, we use the main check to give our Python program a clear starting point. This project brings several Python concepts together in one practical application. If you found this video helpful, please give it a like and subscribe to the channel.